Right. Let's start writing on mass wasting. I think the previous class I explained on the mass wasting under geography. It comes under section 1 of the General Studies 2 for KAS mains exam. So coming to the section, it's under lithosphere, mass wasting under geomorphological process. Let's quickly open. Let's start writing. Give me a moment. Question is mass wasting. It is about movement of rock debris down the slope under the influence of gravity, right? Percentage D star D means it's a definition. This is an NCRT definition. The more you reproduce as it is, it's better. Okay, it aligns to your model answers. Air, water, or ice do not cause mass movements. Write down if people are not writing it. In fact, they are carried along with debris. Okay. Next para. Gravity exerts force on both rock bed and weathered materials as well. Weathering is very important. Weathering is not a prerequisite for mass movement. It only aids in mass movement. Mass movement are very active on weathered slopes. Okay, they're active on the slope, but it's not a prerequisite. Though there is shifting of rock debris, mass movement neither comes under erosion. Okay, it's neither comes under erosion, and weathering is not a prerequisite. It's only about gravity. All right. Take down notes. Mass movement is caused when shearing resistance of rocks over slope is overcome by gravitational forces. Okay, so only the shearing force is overcome by charging force. Following favors mass moment. Okay, it's favoring these situations. That doesn't mean it causes, it favors. Okay, one, weak unconsolidated materials. Like it's not like tightly bound or it's weak, or thinly bedded rocks. Means bedded rocks are not unweathered rocks. Right? If it is too much weathering has happened, only a slight layer of rock bed is remaining. Then that, if it is very thin, the rock bed itself can move down the slope. Then faults, of course, cracks in the rocks. If it is steep, yes, steep slopes. Okay. And then vertical cliffs. So for those who join now, I am actually giving the notes for mass wasting. Okay, I'm also recording the session. If you are not shared your email, just share it. I'll give the recordings so that you can start it. Okay. Um, Vertical cliffs. And 6, abundant precipitation. And 7, scarcity of vegetation. Means there's nothing to stop it. It slides down. All right. Okay, so this is the examples. Then we'll try to structure it out. Right. Hence, following are activating causes of mass movements. 1, removal of support. Okay. 2, increase in gradient is slope. Right. I told Uttarakhand overloading. Right. The activating forces for mass. What is overloading? Addition of materials means like we construct homes on the slopes, right? That is the thing being talked. And other natural causes, heavy rainfall. Okay. Then 4, earthquakes and explosions. Right. 5, excessive and natural seepages. 6, heavy drawdown of water from lakes, reservoirs, and rivers. 7 is indiscriminate removal of natural vegetation. This one I talked about, Dehradun, right? Okay. Next is with types. Types of mass movement. One is heave, right? Flow and slide. Right? Flow is something like a natural water. Slide is a heavy material sliding down. Heave, let me take heave is slow uplift of earth materials, right? You can put a pipe, right? The ice or salts. So when ice and salts become bloated, it uplifts the upper lying earth material. That is heat. Flow and slide, anyway, it's understandable. All right. So next, take down this diagram. That is black. Write this diagram in exam. It may gives you more marks. Flow, slide, and heave. So for flow to happen, it should be both wet, right? Water, wet, and flow is both wet and fast. How about slide? Slide is happens in dry areas. It may be fast, it may be slow. But heave is always slow, but it may be due to wet or it may be due to dry. Got it? So slide and heave has one condition, but flow has two conditions. That's an idea. All right. I think blue is good. Classes of mass moments. One is slow movements. Second is rapid movements. Slow and rapid movements. Let's talk about slow movements. Classes are not important, right? For exam perspective, more important is what are actually the slow movements, right? One is creep. Take down. Movement of materials are extremely slow. The slowest of all mass movement, extremely slow. It is imperceptible except imperceptible means you can't see, except through extended observation. It occurs on moderately steep. If it is high steep, there won't be creep, right? It will go fast. Moderately steep, soil covered slopes. And depending on type of materials involved, it may be soil creep, obviously, or it may be rock creep if rock is involved, right? Or if it is rock, glacier creep in Himalayas, etc., and those places, right? So other type of slow moving movements is, we talked about it, solifluction. Solifluction. Remember, underground water seeps up, right? And it wets the soil and the soil flows down, right down. It involves slow downslope. Sorry. It involves slow flowing soil mass. Not extremely slow, but slow. Not like creep, slow. Flowing soil mass or fine grain rocks. Okay, this happens due to saturation or lubrication by water. This is common in moist, temperate areas where surface melting of deeply frozen ice is observed. Fine. Let's go to next and close it. Next is rapid. Next class of movement is rapid movements. Fine. In this first one, take down. First is earth flow. Second is mud flow. Third is avalanches. Let's take a pause here. Earth flow, I said, is big boulders. Mud flow is flow of mud. Avalanches, which is more destructive. Destructive is more is mud flow, unlike avalanches. Avalanches happens in very remote places where there's no much of human habitation. So that's why it is less prone to destructions. Right. For example, if an earthquake of 10 Richter scale happens in desert, Does it mean there won't be much destruction, right? But even earthquake of 5 or 6 magnitude happens in urban areas, there'll be huge destructions. So that's what it's meant by these changes. So we will continue with notes tomorrow. Okay, I'll give notes for all these three, and then we'll talk about landslides, and then we will pick up the actual erosion and landforms. That will complete the unit one. Okay. I mean, part of the unit one, there's something earthquake, volcanoes, so to go into details. Yeah. Let's find the class for now. Any questions?